Hi, welcome back to Science 1206, the Sustainability of Ecosystems unit. I'm Ms. Ledwell, and in this video, we'll discuss limiting factors. Let's begin. Limiting factors are factors that limit the growth, distribution, or amount of a population in an ecosystem. Limiting factors determine how many individuals of a population can live in an ecosystem. As the population increases, each individual has access to fewer resources. This limits the growth of the population and helps keep the population at equilibrium. Recall that equilibrium is where the amount of new births is approximately equal to the amount of deaths in a population. Limiting factors can be abiotic or biotic. Examples of abiotic limiting factors include dissolved oxygen in a body of water, or something like amount of space or access to sunlight. Biotic limiting factors include things like symbiosis, predation, and competition. There are two types of limiting factors. There are density-dependent limiting factors and density-independent limiting factors. Density-dependent factors are factors related to the size of the population. A population is considered dense when a large number of organisms occupy a relatively small space. So in this image, we see so many frogs in the one pond. This would be a very dense population of frogs, where a lot of organisms are occupying a small space. Density-independent factors are unrelated to population size and often involve changes in environmental conditions that affect the population. Let's look at density-dependent factors in some more detail. Recall that density-dependent limiting factors are factors that are related to the size of the population. So in the image, we see a dense population of hares. There are many hares in a small space. Density-dependent factors tend to be biotic factors. Examples of density-dependent factors include things like disease, parasites, predation, and competition. When population levels are high, the frequency of disease outbreaks and parasites tends to increase. This is because higher population densities lead to more frequent contact among individuals, which increases the spread of transmissible diseases and parasites. Predators often target specific prey species more intensely when their population density is high, resulting in a disproportionately high number of individuals from the dense population being captured. So in the image, we see that there's a high population of trout in this small area, and they are being targeted disproportionately by the eagles. The eagles have other prey opportunities like hare and mice, but they're specifically targeting the trout because the population density is so high. When population levels are high, there is also more competition for resources. Spruce trees in the same area, for example, compete for resources they need to survive, such as water, sunlight, and nutrients in the soil. Now we're going to move on to density-independent factors. So remember, these ones don't depend on the size of the population. Remember that density-independent limiting factors are unrelated to population size. Density-independent factors tend to be abiotic factors. Examples of density-independent factors include weather events like storms, droughts, fires, floods, extreme cold, or heat waves, and pollution such as air, land, and water pollution. A severe weather event such as a storm may result in the death of a number of individuals in a population, reducing the overall population size. Pollution reduces the resources available for a population. Let's take a look at density-independent factors in more detail. So going back to severe weather events like storms can significantly impact a population by causing the direct death of many individuals and the destruction of resources required for survival, thereby reducing the overall population size. Pollution reduces the resources available to a population. For example, every living thing needs water to survive. When bodies of water in an area become polluted, the available quantity of this essential resource is reduced. This can cause the death of individuals in a population, reducing the size of the population. Next, let's look at a new term, carrying capacity. Carrying capacity is the size of a population that can be supported by the available resources in an ecosystem. Limiting factors such as disease, parasites, and extreme weather events determine the carrying capacity of an ecosystem. When a population is kept at carrying capacity, the population is in equilibrium. This graph shows the exponential growth of the northern fur seal and the point at which they reach carrying capacity. So the seal population underwent a period of exponential growth. We can see that in the first part of the graph. This happened when they became protected under a wildlife treaty, which means they weren't allowed to be hunted. So their population numbers went up because there was a reduction in predation. Eventually, though, the population reached carrying capacity. We can see that in this part of the graph where we have the flat line. So here, the population numbers reached equilibrium. There was a similar amount of deaths and births every year. There were little changes in the numbers once carrying capacity was reached, and this is in the years from 1935 to 1950. Now it's time to review. Please complete the learning activities in Brightspace.